All right, so welcome back. Today we're going to be talking about accuracy and precision, two terms that are typically confused and misaligned with each other. Sometimes people think the exact same thing, but it actually isn't. And it's a very important thing to talk about in regards to the scientific fields, the scientific community. So we're going to dive a little bit into it. So the first thing we need to do is describe and define which term, what each term means. So first off is accuracy. The definition of it is that it's the measurement of proximity to an accepted or literature value. So how close can our experiment get close to duplicating a value from another scientist or get close to duplicating a calculated value that we determine through chemical equations and so on and so forth. So in other words, another way to describe it is that it's a measurement of how correct an experimental value is. How correct, how close is it to the accepted value? So it depends on two factors. The two factors is the equipment used in the experiment. If you have bad equipment, you're typically going to have bad accuracy. So you want to try to use the best equipment as possible. But also the second thing is based off the observer or the person doing the experiment, i.e. you. So it really depends on your scientific technique, how well you do the experiment in repeated trials, making sure you do the exact same thing, and so on and so forth. So going into precision, precision is a little bit different. Its definition, it's the measurement of consistency of produced experimental values through repeated trials of the same experiment. So precision is, if we do 3 trials of an experiment, how close are each of those trials numbers together? Are they all like 50, or is there a 50 and a 35 and a 40, so on and so forth? So we'll kind of dive into more of what that means here in just a second. But another way of kind of thinking about it, like I said, is it is a measurement of reproducing the same results. Can you do the exact same thing in multiple trials? It is also a measurement of variation. This is a term that you may have heard in some of your mathematics classes, or standard deviation might be something you've heard of. But it's a measurement of variation, which variation is pretty much the distance between each value. The shorter the distance, the shorter the variation, the better the precision, and vice versa. So to be an effective scientist, you have to have both good accuracy and good precision, which, to be honest, they can take a lifetime to do. So don't expect, in some of these experiments to always think that, it has to be always on point. Of course, there's going to be some error and everything like that, but as long as you do your best and you follow the guidelines, do the exact same thing in each trial, and try to be as precise and accurate as possible, that's what I'm looking for in this classroom. So the best way to kind of describe accuracy and precision is that, accuracy you can kind of set up like if you want to think of mathematically, you can be on the y-axis, precision can be on the x-axis, and how close can you get to the center point. The most visual representation that's heard of is a dartboard, which I've tried to illustrate here in this video. So the way it is, the best way to describe it, like I said, is using a dartboard for visualization. So imagine that I throw 3 darts. Each dart represents a separate trial of an experiment that I just did. So I do one trial, I get one value. I do another trial, I get another value. And I do another trial, and I get another value. So how would you describe this experiment? Well, if we look at the center of the dartboard being the bullseye, that's the accepted value. That's the value that we're kind of shooting for. That can help determine how accurate we are. But the precision is how close the darts are going to be together. So if I was to describe this experiment based off this analogy right here, you could say that this experiment is somewhat accurate, but not that precise. And why is that? Well, we know that one of the darts hits the bullseye, and the other one's not that far away from it. So we know it's pretty accurate. But in regards to precision, there's one that's way off. This is what we call, what you can hear sometimes in mathematics called an outlier. So that actually skews the precision away from the experiment. So we did hit, in this experiment, we're saying that we hit the value on the dot and really close, but then not far at all, which means that, maybe our equipment is good, but maybe our technique wasn't good in regards to this experiment. So again, the bullseye being the accepted value, and then and not being precise because that third dart is a little bit off. So let's do another example. So let's say I throw a dart, I do a trial, I get one here, and I get another value of here, another value of here. So how would you describe this experiment? So if you need to take a second, think about it, go ahead, and we'll dive into it. All right. So based on the position of the darts, we can both say that this experiment is neither accurate nor precise, which means that our equipment probably really sucked and our technique really sucked, which means we're not getting good values, we're not anywhere near that bullseye where we're wanting to go, which means we really need to reevaluate what we're doing, how we're doing it, so on and so forth. Now, being more accurate, precise does not mean it's a bad thing, especially if you're trying to dive into new concepts in science. I mean, sometimes the things that don't make sense turn out to be the things that make sense along way down the line. But for the stuff that we do in this classroom, I mean, it's going to be based off accepted and literature values that have already been proven. So we need to make sure that we try to be as accurate and precise as possible. That way, when you do go further into the scientific field, if you decide to do that, you can have those skills to actually start exploring those new ideas and so on and so forth. So again, it's not accurate because they're nowhere near the bullseye, and also they're not precise because none of those darts are really close together. So the variation, the distance between each dart, this is a great variation at great distance, which means the precision is really bad. And same thing here, that's either a greater distance between these two, so very bad precision there, since there's such a great variation between them. Again, just what we just talked about. So let's take another one. Do a trial, hit the dart, hit a trial, hit the bullseye, do another trial, hit the bullseye. So right on the money with all three trials. How would we describe this experiment? So take a second. All right. So you can describe this experiment as both being very accurate and very precise. Why is it accurate? Because all three of them hit the bullseye, so it hits the accepted value each time. It's really precise because every single dart is within the same area, so which means that your technique would have been fantastic and pretty much perfect on this mark, which is what we're looking for in the science field, scientific community when it comes to writing papers and everything. But this is what I want you to strive for in my classroom. You know, there's always going to be things that happen in the experiment, but it doesn't mean you can't be accurate and precise, both in regards to your technique, but also how you describe any error or anything that occurs within the experiment. So again, they hit all the bullseye, the accepted value, and they're really close together, so which means the variation between each dart, the distance between each dart is very, very small, which means that very low variation, which means a greater precision. So kind of do an example, you know, tabular data-wise, is suppose I perform a mass determination experiment of a Tums tablet to observe the relative mass of what's called sodium bicarbonate, which you may hear is it's in your baking powder, baking soda, stuff like that, within one particular tablet. Now, if you ever look at a Tums tablet, it'll actually tell you the relative mass of how much sodium bicarbonate is in that, or at least should be in each tablet. So typically the most accurate relative mass of sodium bicarbonate is about 500 milligrams of sodium bicarbonate per each tablet. So that's the accepted value, the given value that we're trying to shoot for. So that's the bullseye we're trying to shoot for. So I do the experiment, and my results are as follows. My first trial, I have about 495 milligrams compared to the 500 that I should get. Second trial, 394 out of 500, and then 510 out of 500. So obviously, you know, they're around this. Some of the values are around the 500 area, some are a little over, some are really below. So kind of just looking at this data table, you can kind of tell what could have happened during my experiment. Was my technique bad? Was there something wrong with the equipment? So on and so forth. So in this experiment, would you describe the experiment as accurate, precise? I mean, how would you describe it? So take a second and kind of think about it, see what you can come up with. Again, just write down your answer, give reasons for your choices. That way we can kind of discuss it in class further if we need to. All right, I'm going to leave that go. We'll leave that alone. We'll talk about that a little later, probably in class. So suppose I have a student perform the exact same experiment that I just did. Same accepted values, same materials, everything like that. The student performs the experiment, and his or her results turned out to be this. So you can definitely tell that the student had values really close and on the money in regards to the accepted value, maybe a little bit over on the second trial. So that typically tells me, you know, he or she had really good technique. The equipment they were using must have been really good. So how would you describe that based off of that? You know, would you say it's very accurate and very precise? I would. I definitely would. So, again, based off both of the examples, how can you tell about the technique? Well, if he or she is hitting the same values each time, they're doing the exact same technique in the exact same way, which is what we're looking for. We want consistency. That's what helps precision. Accurate, because it's hitting right around the 500 area, so that's exactly what we're trying to shoot for. So again, if you think a little bit differently, just take a minute, write down your responses, your reasoning behind this based off what you see in the table, and bring it to class. We can talk about it a little bit further if need be. All right, so that's all there is in this video. I know it was kind of relatively short compared to the other ones, but two very important concepts. We'll really dive further into what this is with error analysis as we do labs and everything like that too. So if you have any questions, please come talk to me. I'm more than welcome to help, and I will see you soon in class and in the next video. Bye.